Hey everyone, in this video we'll talk about how to graph a function and all about how to deal with functions on a graph. So as you can see right here, we have this equation graphed, y equals 2x plus 1, and as you could see, its y-intercept right here is positive 1. You could see at this point it hits 0, 1, and then it has a rise of run of 2 over 1. Its slope is right here, 2 over 1. So it goes up 2 over 1, up 2 over 1, and in the reverse direction, down to left 1, down to left 1. So the entire time, this is an increasing graph right here. It's an increasing line. It goes up 2 over 1, up 2 over 1, up 2 over 1. So that is, this is a graph, y equals 2x plus 1. Now, let's talk about this in the context of a function. So, with a function, remember we have a function f of x. So, f of x, that is the functional notation, and x, right here, represents our input. X is our input. So, remember, a function is just like a machine. You put an x in, and you get f of x spit out. So this equation right here, y equals 2x plus 1, is not too different. We have an x right there, so we have an x right here in this equation, and we have what y equals right here, y. So what we're going to do, we're going to set f of x equal to y. And what that will allow us to do is we are going to go ahead and replace this y. We are going to substitute it for f of x. So f of x equals 2x plus 1. And there we go. That is this graph in functional form. So how you read this is very similar to how you would read a graph for a normal equation. If we take this point right here, we could see right here, this is 1, 3. So I'll write that 1, 3. What is 1 and what is 3? So 1 is the x coordinate. So 1 is the x. So x equals 1. And what is the 3 right here? So the 3 right here is the y coordinate. 3 is the y coordinate. So y equals 3. But what did we say y equals? We said y equals f of x. In other words, f of x equals 3. So let me write that over here. F of x equals 3. So how functions are graphed, they're very similar to graphing equations. And the x-coordinate represents the input, and the y-coordinate represents the output, x, f of x. So that's how it would be read. Now, we know how to test if a relation is a function by taking a look at the inputs and outputs and seeing if any input has more than one output. So right here, let's just rewrite this as f of x. This is f of x equals 2x plus 1 right here. So what we're going to do, we're going to learn about a new concept. It is called the vertical line test. Vertical line test. So what the vertical line test will tell us, if a graph passes the vertical line test, then the graph is a function. So if this right here, f of x equals 2x plus 1, if it passes the vertical line test, then it is a function. So let's go ahead. How do we perform the vertical line test? What we are going to do is we are going to draw a vertical line at every x value on the x-axis right here. So on this x-axis right here, we're going to draw a vertical line going from top to bottom. And the point is, if any of these vertical lines touch the function, if it touches this graph, the orange line, if it touches it more than once, then it's not a function. So as long as none of these lines touch the graph more than once, then it can be a function. So let's go ahead and draw our vertical lines. So we'll draw a vertical line top to bottom here at x equals -2. And as you could see right here, it touches the line just once. And we'll do it again. We will draw another line from top to bottom at x equals -1. And again, it only touches the graph, the orange line, once. And we're going to do that at every x value. So x equals 0. It only touches it once right here. And x equals 1. It's only touched once right here. And x equals 2. So it's a little hard to see with this arrow, but if we just extend this line just a little bit, and then we draw our vertical line, then it only touches it once right there. So all of these vertical lines, all these red vertical lines that we drew, they only touch the graph once. So it doesn't touch the graph more than once. It doesn't touch it twice, 3 times, 4 times. No, it only touches the graph, the orange line, once. So that means it passes the vertical line test. And if it passes the vertical line test, then we know this is a function. So we know for sure this is a function because it passes the vertical line test. Now let's just give an example of a function that doesn't pass the vertical line test. So let me go ahead and erase these red lines right here. Let me just put that back. And okay, let's just do this. Let's actually just undo all these. There we go. Okay. We can get rid of those. Excellent. So let's go ahead and give an example of a function that doesn't pass the vertical line test, or rather a graph that doesn't pass a vertical line test. Because if the graph doesn't pass the vertical line test, then it's not a function. So let's say we had a graph right here. Let's say y equals, so actually let's just draw it over here. Let's say we had this circle right here. We had a circle. Okay, so we have this circle right here, and let's just call it g of x. So we don't know if it's a function yet, but let's test to see if it is a function using the vertical line test. So we're going to do the same thing, and let me actually just move this over here to another spot. Let me just move it up here. Okay. Let me put that arrow back. Okay, so we're going to do the same thing. We are going to draw vertical lines on this g of x right here, on the circle. And if any of the vertical lines touch the graph more than once, then we know that it is not a function. So let's draw a vertical line here. And right here, it happens to touch the graph just once, right on the edge right there. Okay, so that line is good. It only touches the graph g of x once. And let's draw another line right here. Now check this out. Right here, this vertical line that we drew at x equals 4, it touches the blue circle twice. So it touches the blue circle twice, and that's it. We stop our test right there. This has already failed the test. It failed the vertical line test. So g of x is not a function. So this is not a function. It's because it failed the vertical line test. So we know this circle right here, it's not a function. Okay, so that's how the vertical line test is used. And now, real quick, let's get back to relations and functions, and let's talk about a special type of function called one-to-one functions. So a one-to-one function. So let's say we had this relation right here. Let's open up our curly brackets, and we had all these ordered pairs in our relation. say we had 1, comma 3, comma 2, comma 4, comma 3, comma 3. Okay. And then to test if this relation is a function, so we want to know if this is a function, we're going to do what we did in our previous video. We will write down all of our inputs, so all the x-coordinates. So all our x-coordinates in green are 1, 2, and 3. So 1, 2, and 3. And then we will jot down all of our outputs. So all our outputs are the y-coordinates, the ones underlined in orange. So 3, 4, and 3. 3, 4, and 3, but 3 is a repeat. 3 is a duplicate, so we can just have 3 written once. We can just have it right here. We don't have to write 3 again. And then let's go ahead and draw arrows representing each relationship. So 1, comma 3, 1 goes to 3 in this first ordered pair. So 1 goes to 3. And in this ordered pair, 2 goes to 4, 2 goes to 4. And in this ordered pair, 3 goes to 3. So 3 goes to 3. Okay, now is this a function? Well, to test if it's a function, we're going to look at each input right here, 1, 2, and 3. And we're going to see, do any of them have more than one output? So number 1 right here, how many outputs does 1 have? Well, 1 only goes to 3. So it only has one output, so that's fine. How many outputs does 2 have? 2 only goes to 4. So that's it. It only has one output. So that's fine. And 3 only has one output as well. 3 only goes to 3, doesn't go anywhere else. So that's totally fine as well. So let me go ahead and just remove those colors. Okay, so we know that all of our inputs only have one output. So this is a function. This right here is a function. But now, is it a one-to-one function? So a one-to-one function is a special type of function. It is a function where all of the outputs as well, they all only have one input. So let's test to see if this is a one-to-one function. We'll go ahead and take a look right here at all the relations and all the arrows. And now we're going to test the outputs. We're going to test the outputs. So let's actually start with 4. How many inputs does 4 have? Well, 4 only has one input, this 2 right here. So that's fine. It only has one input. But now this 3 right here has 2 inputs. Let me make this a different color. So it has 2 inputs. It has one input coming from 3 and another input coming from 1. So this has 2 inputs. And what that means is that it is not a one-to-one function. So this right here, this relation, it is a function, but it's not one-to-one. Because in order for it to be one-to-one, every output also has to have only exactly one input. Now let's modify this function to make it one-to-one. So let's modify this function right here. And what I'm going to do is, let's just erase all this. So let's just get rid of all of this. Okay, and what I am going to do is I'm going to tweak this function a little bit. So instead of right here, 3, 3, I'm going to write 3, 7. Okay, so we have a different relation right here. Let's go ahead and test to see, is it a function? And then if so, is it a one-to-one function? So we'll do the same thing. All of our inputs, we'll jot down 1, 2, and 3. So our inputs, 1, 2, and 3. And we'll jot down all our outputs, 3, 4, and 7. So our outputs, So our outputs are 3, 4, and 7. And let's go ahead and write down all of their relations. So this first one, 1 comma 3. So that means 1 goes to 3. Right here, 2 comma 4, so 2 goes to 4. And 3 comma 7, that means 3 goes to 7. And we're going to test it. First, we're going to test to see if it's a function. And to see if this relation is a function, we're going to look at all the inputs right here. So this first input, it only has one output, this one, so that checks out. Now, this second input, 2, it only has one output, 4, so that's fine as well. And this third input, 3, it only has one output, 7, so that checks out as well. And now, we know all the inputs only have one output, so we know this is a function. So we know it's a function, but now let's check to see, is it a one-to-one function? And we're going to do that by checking all the outputs. So let's go ahead and do that. We have 3 right here. 3 only has one input. It only comes from 1. So it only has one input. That's fine. 4 only has one input. It only comes from 2. So that is fine as well. And 7 also only has one input. It comes from 3. So that's fine as well. And there we go. All of our outputs only have one input. So that means this is a function, and it's a one-to-one function. So this is a one-to-one function. Excellent. So now going back to our graph, if we scroll back up, we know the vertical line test. So the vertical line test, it tests if the graph is a function. And we know f of x right here, it passed the vertical line test. So we know this is a function right here. This is indeed a function. So I'll put a little check mark. But how do we know if it's a one-to-one function based on the graph? So to know if it's a one-to-one function just based on this graph right here, we are also going to use the horizontal line test. So the horizontal line test. If you use the horizontal line test on a graph that you know it's a function, if it passes the horizontal line test, that means it's a one-to-one function. So the horizontal line test is very similar to the vertical line test. What you're going to do is you're going to draw horizontal lines at every y value, and if it touches the graph more than once at any line, then it fails the horizontal line test. So let's go ahead and we'll start from the bottom. We'll draw a horizontal line at y equals -3. And right here, it only touches it once, so that's fine. It doesn't touch it more than once. And then we'll draw another one at y equals -2. Again, it only touches once. And we'll keep going like that. Y equals -1. Only touched once. Y equals 0. Only touched once right there. Y equals 1. It only touches it once. Y equals 2. Just once. And let's just finish it up. Y equals 3 is just once. Y equals 4. Let me draw a better line than that. Y equals 4 just once. And y equals 5 just once. There you go. So every horizontal line that we drew, it only touches the graph once. So that means that this right here, the f of x, it passes the horizontal line test. And let me just go ahead and get rid of all these lines. Just get rid of that as well. There we go. So it passes the horizontal line test. And what that means is that f of x is not only a function, but it is a one-to-one function. So f of x is a one-to-one function. Good. F of x is a one-to-one function. and that's how we prove it based on the graph. So I really hope this video helps, and if you have any questions at all, please leave them down in the comments below, and thank you so much for watching.